name is Jimmy Yang. I will continue to talk about CM elliptic curves over number fields with complex conjugation. This is the second part. Review of the delta k less than -4 case. Let us outline the proof of the computation of the fiber from x0 of m, n to x1 over the closed delta Cn point J delta on x1 given in another paper, so that we can see what must be modified to treat the delta k belongs to -3, -4 case. There are following steps. The step 1, we handle the case s0 of 1 common L to the s power 2 is equal to x0 of L to the s power for a prime number, for a prime power L to the s power. So step 1a, the L power isogeny graph corresponding to a delta Cm elliptic curve with delta is equal to L to the 2L's power times f0 to the second power times delta k, where GCD of L common f0 is equal to 1, has the structure of an L isogeny volcano. This is an infinite graph that is very close to being a rooted tree and with vertex set stratified into levels indexed by z. The set of vertices at level L corresponds to the set of J invariants of delta is equal to L to the 2L's power f0 to the second power delta k Cm elliptic curves, which is a tensor under Picard group of O of delta. That is the Picard group of imaginary quadratic order O of delta of discriminant delta. Cyclic L to the s power isogenies with delta Cm elliptic curve correspond to pace with length a in this volcano with initial vertex at level L. From this, it is easy to see that if phi from E to E prime is such an isogeny, and if the target elliptic curve has level L prime, then over K, the field of marginally of phi is the ring class field, K adjoint with F0, L maximum of L prime, which is equal to K adjoint with J invariant of E, J invariant of E prime. It follows that Q adjoint with J of E, J of E prime is contained in Q adjoint with phi, which is contained in K adjoint with J of E, J of E prime. Step 1b, thus the field of marginally Q adjoint with phi of phi is determined when Q adjoint with J of E, J of E prime contains K. This happens if and only if Q adjoint with J of E, J of E prime has no real embedding. J of E and J of E prime are not co-real. Okay, the concept is whether two J invariants are co-real. Otherwise, we are left to decide whether Q adjoint with phi is Q adjoint with J of E, J of E prime, or K adjoint with J of E, J of E prime. Both the correality question and the dichotomy between the two possible fields can be answered in terms of the nature action of complex conjugation on the L isogeny volcano, determining the explicit action of GR, which is equal to 1, C on the L isogeny volcano, is one of the main contributions of CL22A, which is another paper. In the end, depending upon whether or not the path is fixed under complex conjugation or not, we get that Q adjoint with phi is isomorphic to Q adjoint with F0 L to the max of L, L prime. That is isomorphic to a rational ring-colored field, the field obtained by adjoining to Q, the J invariant of an elliptic curve with Cm by the imaginary quadratic order of discriminant F0 L to the max of L, L prime square delta K, or to the ring-closed field of K adjoint with F0 L to the maximum of L, L prime, which is obtained by adjoining to the K the same J invariant. Okay, thank you.